Hello, welcome to my channel. You can find the worksheet below this video. Let's start our lesson. The number lesson 1, prime factors. Today we are going to learn prime factors, and in this lesson there are 4 parts: factors, prime and composite numbers, and prime factors and prime factorization. The first part is factors. So what is factor? And a factor is a number that divides another number, leaving no reminders. And in other words, we can find, for example, like factor A times factor B and equals C. And in this way, and A and B are the factors of product C. And A, B, and C are whole numbers. So this is factor. Let's look at some examples. For example, A, and for 8. For 8 we can find the factors. The first pair we can find 1 times 8. And it's 1 and the number itself. The second pair we can find 2 times 4. So the factors are 1, 2, 4, and 8. And let's see numbers. Let's see how many numbers of the factors, and the number is 4. Okay, because 1, 2, 3, 4, we have 4 factors for number 8. So let's look at B, 21. And 21 we can find one first pair is 1 times 21. The second one we can find is 3 times 7. So in this part the factors are 1, 3, 7, 21, and there are 1, 2, 3, 4, and there are 4 factors. And problem C. The first one is 1 times 22, and then the second pair is 2 times 11. So there are the factors are 1, 2, 11, 22, and there are 4 factors, 1, 2, 3, 4. Okay. And the next one is 33. 33, and the first pair is 1 times 33, second is 2 times 18, third one is 3 times 12, and the 4 is 4 times 9, the last one is 6 times 6. So in this one the factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And in this way, how many factors? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 factors. And after the factors, let's look at the prime and the composite numbers. And the prime number is defined as a whole number which has exactly 2 factors or only 2 factors. And in this way, the two factors and always, let's look at our example for here. And if we look at our problems, so for 8 it's always 1 and itself, for 21 1 and itself, and 36 1 itself. So the two factors is always 1 and the number itself. And for example like 3, it's only 1 and 3, and or example 7, it's only 1 and 7. And for composite number, a composite number is a whole number which has more than 2 factors, and maybe 2, maybe 3, maybe 4. And for example, number 8, and we have 1, 2, 4, and 8, and which has 1, 2, 3, 4 factors. Or 9, and we have 1, 3, and 9, and we have 3 factors. And so these two are composite numbers. And in this part we have 2 special numbers. They are 1 and 0. So the number 1 has only 1 factor, is itself. And it's neither prime nor composite. And number 0 in this course is defined to has no factors. Okay, let's look at some examples and classify the following whole numbers are prime or composite. The first one is 41, and for 41 we only can find 1 and itself, 41, so this is a prime number. And B, 42. 42, we can find the first pair is 1, 42. Because this is an even number, so, and we can find another pair is 2 and 21. And also if we have 2 and 21, we have 3 and 7. And this can break to 3 and 7. Because this 42 has more than 2. Now we have 1, 2, 3, 4 factors. So we know this is a composite number. Okay, and next one is 103. So this is only 1 and itself, so this is a prime number. And then next one, last one, is 169, and this one is the first pair is 1 and 169, and there's another one is 13, because 13 squares equals to 169, so this is a composite. And we learned prime numbers and factors. Now we can put these two things together. So we have prime factors. And the prime factors of a whole number are the factors of number which are prime. So here's the definition. Okay, let's look at some examples. And A is state of the factors of 20. And in this way, for 20, we can find first pair is 1 times 20, second one is 2 times 10, third one is 4 times 5. So the factors are 1, 2, 4, 5, 10, and 20. And B, state the prime factors. And the prime factors, let's look at the factors and to choose the prime factors. 1, no. 2, yes. 4, no, because 4 we can break to 2 and 2. 5, yes. 10, no. 2 and 5. And 20, of course not. So the prime factors are 2 and 5. And express 20 as a product of prime factors. So you need to write only prime factors. So we can write 2 times 2 equals 4 and then times 5 in this way. Okay, and let's look at some practice. And state the prime factors of A, 45. So 45, we can find the factors like 5 and times 9. And in this way, 5 is 9. No, 9 we can break into 3 times 3. So 3 is prime factors. And in this way, the prime factors are 3 and 5. And next one is 66. 66 we can write in 6 times 11. And 11, yes, is a prime factor. And 6, no. And 6 we can break to 2 times 3. And 2 is prime factors. 3 is prime factors. So the prime factors are 2, 3, and 11. Okay? Now let's look at the last part and the prime factorization. And the prime factorization is impressing a whole number as a product of prime factors. It's called the prime factorization of a number. Here's the definition. And prime factorizations, there are two ways, and one is division table, the other one is tree diagrams. Let's use the number 48 as an example. And for this one, and for the division table, and we can try the lowest prime number or smallest. So the first one is 2. And then 48 divide 2 is 24. We can still divide 2 and it's 12. and divide 2 again, we can have 6, and we can divide 2, and then so. And the last one is 3, and the 3 is a prime factors. And in this way, and this one we can find the prime factorization, and then we can write in 2 times 2 times 2 times 2 times 3. Or if you think it's too long, we can write like 2 to the power to the 4th power and times 3. So this is an easy way. And the tree diagram is we can break them into 2 parts each time. So the 48 we can break them to 6 and 8. And for 6 we can break to 2 and 3, and for 8 we can break to 2 and 4, and 4 we can break to 2 and 2. So, and then we can write is 2 times 3 times 2 times 2 times 2, or 2 to the 4th power times 3, and these two answers should be the same. Okay, let's look at more examples and use division table and a tree diagram to determine the prime factorization of A and B. Okay, so for A is 1925, and let's see, the first way is division. It's 1925, and if you know the divisibility rule, a number is divisible and by 5 if it is and in 0 or 5. So this is 5, so we can try 5 first, and it's 385, and the and is still 5, and we still can try 5, and it's 77, and 77 we can try 7, and then last we get is 11. So we can write in 5 times 5 times 11 times 7 times 11, or 5 squared times 7 times 11. And for the tree diagram, so 1925, and we can write so 25 times 77, and break 25 to 5, break 77 to 7 and 11, and then we can express as 5 times 5 times 11 times 7, or I hope it's 6, read the wrong number, and 5 squared times 7 times 11. Yes, this time is correct. Okay, and for the B, and 6,762. So division, and 6,062, and we can try 2 because it's an even number, so it's 3,381. And in this way, and based on the divisibility rules, and if all the digits end up to a number is divisible by 3, so this number is divisible by 3, and this is, we can add this 3 and 3 is 6, and plus 8 14, and plus 1 15. So this number is definitely divisible by 3, and then we can divisible by 3, and we can get 127. And for this one, if we add this all digits together, is 11, and it's not divisible by 3, so we can try 5, maybe not, because it's not and in 0 or 5, so we can try 7 this time. 7, we can get 161, and we can try 7 again. So the answer is 23, and 23 is a prime number. And we can express as 2 times 3 times 7 times 7 times 23, or 2 times 3 times 7 squared times 23. And we can try the tree diagram. And for the tree diagram, we have the number, and then we can break them into 6 and 1127. And then 6 we can break to 2 and 3. And this one we can break into 49 and 23. And 49 we can break to 7 and 7. So we can write 7 times 2 times 3 times 7 times 7 times 23. So this is today's lesson. Thank you for watching. If you like my teaching, please click the subscribe button. Please let me know your questions in comments.